Well, on this particular part, this is our 400-ton machine. We're going to run a very complicated part with very complicated slide actions. On this part, you can also see that the customer's concern was sink in this area underneath that's a sealing surface, so we put an RJG and a cavity sensor there. On the other side of the part, we put a post-gate sensor for our control point. So what we're going to do is we're going to control off of this point, and we're going to monitor off of this point. If we get to a certain pressure here, we know we packed that sink out. On this part, you can also see that it's very, very complex, so that we're going to have some awful big slides and complexity to the tool. So as the mold opens, you'll also see that the robotics are going to come in and grab this part out. We got big slides on that side. The robot's going to come in and grab the part out. And we have a stripper plate. When the stripper plate retracts, you're going to notice an unwinding core that winds in. So it's a very complicated part and a very complicated tool. As you look at the screen over here, we're going to actually see that pressure's charting on the screen. The green line that's charting across is the actual post-gate sensor, our control point. The blue line that's charting across is the end of cavity sensor, or our monitoring point. The dotted lines that you see on the screen are our templates, and the red line that's on the screen is the actual plastic pressure the machine is using. We can use the templates to compare the solid line to the dotted line to see if we're running a good part. We also have on the screen our cavity pressure set point screen, where we're telling the machine to go to 6,500 psi inside the cavity and then stop. We know that that number gives us a good packed out part. With the alarm settings down here, we know that if our peak end of cavity is above 5,800, then we have a good part. That will send a signal to the robot if it's below that to reject that part and put that part into a different location than all the other good parts. So we truly know before the mold opens whether the parts are good or bad.